Okay, a scale factors question with volumes and with length. So I'm going to quickly run over what happens here. So here I've got a 3D shape being enlarged. So the linear scale factor, let's just say my linear scale factor, that is how much one side increases to the other. So whatever it is, let's just say my linear scale factor is x. So if I multiply what I've got on the left by x, that smaller cube, I get the length of side on the right. Now that affects the area scale factor. So actually the area of one of the faces of my cube on the left is going to be bigger. I'm going to multiply it by the width and the height. So if the linear scale factor was 2, the area of those faces would be 4 times bigger. And the volume is the same as having it cubed. So if I double the length of a side of a cube, I actually multiply the volume by 2 cubed, which is 8. So that's our key bit of information, the stuff that I've just circled here. Using that, this question gets a bit easier. Okay, so let's look at it. We were actually given 2 volumes. We're given 30 litres and 20 litres. So from that, we can work out the volume scale factor. So the volume scale factor is what it takes to get from 20 to 30, or you could do it the other way around. So my volume scale factor is going to be 1.5 or 3 over 2. So the volume is getting 1.5 times bigger. You could do it so it's 2/3 as well. You'd get the same answer, but just divide later rather than add. So that means my linear scale factor is going to well, I know that I'm here. I'm at the here at the x cubed. I need to know what that is. So to get from that to that, I need to cube root it. So it's going to be the cube root of 1.5. Now it's going to be a really awkward number. So I'm not going to work it out and write it down. Just to figure out what I need to do. So that means that to get from my smaller one to my larger one, I need to multiply by the cube root of 1.5. So to go back the other way, let's just use this as an example. I know the volume to get that my linear scale factor, is multiplied by the cube root of 1.5. And I know this length is 53. We've got a very awkward cube backpack here. So to get back that way, I need to do the opposite. I need to divide by the cube root of 1.5. So I'm going to take 53 and divide it by the cube root of 1.5. I've run out of space here, so I don't like just putting this in a random place, but that is what I'm doing. So the length will be the cube root, 53 over the cube root of 1.5. Which gives us 46.3 to 3 significant figures, 46.3.